The concept for e-part trade is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for e-part trade is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and to get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
You can go to epartrade.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At e-part trade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you know you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of e-part trade. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
E-part trade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Morning from California. It is 9 o'clock here. I am Francisque Savignan, the founder and CEO of e-part trade. Welcome to Race Industry Now, the technical and business webinar series from e-part trade presented by ARP. This morning with me is Judy King, co-founder. Good morning, Judy.
Good morning.
And then the wonderful Brad Gillie. How are you, Brad?
I'm doing great. I hope you're doing all well also, Francis.
Absolutely. We had a busy week here as well, right, Judy?
Yeah, so I mean, we've had a handful of new suppliers jump on board. We have Sport Compact Specialist Tomei, a brand new ATC bolts and fasteners, brand new startup company, MCO Gears, somebody I worked with at PRI for 20 years, and Ineos Lubricants, excuse me.
Yeah. Well, we've been very busy in recent weeks, and today this is going to be episode 117, and we are going to bring some great friends, old friends. Lake Speed Jr. and Keith Jones from Total Seal Piston Rings. Lake was instrumental helping us start this series of webinars a year and a half ago. And then we're also going to bring Ed Kiebler from Rottler. So those three panelists have been on our series before. So welcome back, gentlemen. I see Lake. I'm getting a signal from our producer, Reed Keneski. Good morning, Lake. How are you?
Good morning, everybody. I'm doing well. It's here almost lunchtime, North Carolina, I guess. But so we're through the miracles of the internet, right? I'm in North Carolina and Mr. Jones is in Arizona, and we're working back and forth every day. It's extremely busy in the industry right now. Everybody is racing and going and doing. It's pretty fun right now, actually.
Absolutely. Oh, I see Ed. I see Keith. Good morning, Keith. Good morning, Ed.
Good morning.
Right,
Good morning.
We'll let you take over. We're here to listen to those wonderful speakers. So you guys are on.
All right. Thank you very much, Francis. Really appreciate that. I always love it when we get to come on here and talk about making power and efficient ways to do that. And today's webinar is titled Make More Horsepower Through Surface Finish and Geometry. And as Francis get introduced everyone, Lake Speed Jr., a tribologist, Keith Jones, the Director of Technical Sales for Total Seal Piston, and Ed Kiebler from Rottler. So gentlemen, this is going to be a lot of fun, and I know we've been a part of these before, which has always been awesome, but really looking forward to it as well. Ed, we said hello to you. I want to say hi to Keith Jones as well. Keith, welcome. How are you today?
Doing great. Good to see you.
Awesome. Fantastic. And Ed Kiebler from Rottler. Ed, welcome as well. I don't know that I've had the pleasure of necessarily chatting with you, but I'm really looking forward to this as well.
I don't think so, Brad, but I'm feel the same way. I'm looking forward to it. I tell these guys all the time, I always learn something. I'm situated in the middle here, in between two of the smartest guys I know.
I like
Who's that? Well, I don't see Billy Godbold anywhere in the room, so there's no smart guys in this room.
Yeah, I'm certainly on the outside of that as well. And I actually want to start with you because this morning I've been doing like a deep dive on Rottler, which is pretty fascinating. What the company does and what the company has done, been around since 1923, and the equipment and everything that you provide. So give us a little bit of a background about Rottler and what you guys are about.
Sure. We, as you said, gosh, I guess we've been in the business now 98 years. We're going to celebrate our 100th anniversary in 2023. We started out as a cylinder boring company. I mean, the old manual where you literally turn the spindle and you fed the cutter bit down through a bore as you were turning the spindle, Brad. So, and we've just grown the company by leaps and bounds and new technology. You know, I always tell our customers is we don't do anything else. We support the automotive business, period. And that's really the performance and the reman business. We're not in the OEMs. We're very focused on our customers and what they need to compete in the marketplace and try to grow their business and increase their profits.
And when it comes to a lot of, oh, I'm sorry, go ahead.
Go ahead. No, go ahead.
I was going to say, you guys also have a relationship with Roush Yates Engines as well. Can you talk about that a little bit?
Yeah, sure. Great relationship. You know, Doug Yates is one of the finest individuals I've ever run across in my life. Just a sincere individual. Todd English, his right-hand guy. They've just been wonderful to us. We have a great relationship with them. We have our cylinder hones in their cup facility where they hone all their cup engines with our cylinder hones, and then we have our block machining center in one of their other performance divisions, and just been a wonderful relationship with those guys. You know, learned a lot, and they've opened up a lot of doors for us.
That's fantastic. All right, Lake Speed Jr., give us an idea of what we're going to be talking about here today. I know the last time we had you on here, I think we probably could have talked for about 5 hours on everything, and we certainly got a lot of questions from the chat, which is great. And I do want to encourage people, if you have any questions about anything we're talking about here today or about Total Seal or Rottler, please feel free to put them into the chat, and we'll get to as many as we can. But Lake, what are we talking about here today?
My favorite topic, Brad, making more horsepower. Right? At the end of the day, everybody wants to make more power. And the number one way of making horsepower is getting better ring seal. And we've talked about that before in a couple of different ways. And obviously you're trying to reduce friction, but the main thing is, you know, an engine is an air pump. So you want that air pump to be as efficient as possible. And all the real top engine guys kind of all know that it's getting that ring seal, and I always call it a soup. It's soup, not steak. It's that combination, the synergy between the piston and the rings and the cylinder and the oil. That all has to work together. And one of the real secrets to this is the bore geometry and the surface finish, because the surface finish is what's going to hold the oil to be that gasket between the piston and the ring and the cylinder wall, because obviously gasket is there to seal those differences, because there's going to be differences. But that bore geometry is the thing that is it's the hardest thing for most shops to measure. There's a really high-end piece of equipment called an incometer or a pat gauge that can actually measure how round a cylinder is top to bottom. The best analogy I can always think of is a slinky. All right, if you can imagine a slinky, if you had a dial bore gauge and you measured that slinky at the top, in the middle, and the bottom, it'll be round. But it doesn't necessarily straight, though. You can offset the slinky this way. You can bend it over. It's still round, but it's not straight. So think about straightness not only in terms of what that friction can be, because if the piston's having to do this, now that's exaggerated, right? We know it's not really doing this, but on a micron level, it is doing this or doing this. So if you can get it straight, it's going to be more efficient from a friction standpoint, but also too in terms of it actually the ring being able to follow it, because the ring can only follow, you know, a certain amount of deviation without it skipping. When it skips, now there's a chance for blow by. So I'm going to start off with a very little story real quick. Then I'm going to let the two really smart guys that have a lot of experience share on it. But a friend of mine is a go-kart engine builder, and he builds some really, really great go-karts. And if anybody thinks much about go-karting, well, push away. When you only have one engine and it only makes 5 horsepower, everything counts. There's no room to give up because you ain't got much to begin with. So he shared with me some of his surface finish numbers. And I shared those with a buddy over in Europe because they don't compete, right? This guy's here in the US. This my friend. These other guys are over in Europe. They're never going to compete with each other. I said, here, try these numbers. And he worked a little bit on his own to get those numbers. On a 5 horsepower engine, he picked up a 1/4 of a horsepower. That's on a percentage basis, that's huge. I mean, he's tried all kinds of other things. When you find a full 1/4 horsepower just by changing your surface finish, that's a big thing. So that's what the conversation today is about. How do you unlock that hidden horsepower that's right there in front of you? Surface finish, board geometry is a big part of it. And again, Keith and Ed are the two masters of this. So actually, let's let Ed talk a little bit about the board geometry, because that's the thing that most people can't measure in their shop. Ed, tell them about what the dial bore gauge can't tell you.
Oh, it's exactly right, Lake. You know, a 2-point contact cannot gauge or what true roundness is. And so we all use our dial bore gauge, and boy, we go down through there, you know, some of the better shops have the 10th reading gauges, and they go, look at this, man, this thing's perfect. Okay. And what happens is they really don't know. The slinky is the best analogy that I have ever heard. That's just a perfect analogy, because the cylinder may not be straight. It gauges straight because it only checks in 2 points. But that's horsepower, and as you said, and so the other thing you get into is bore geometry, the roundness of the bore. And in today's motors, you know, the cylinders are getting thinner, and you have some supported and unsupported areas in the cylinder. And what happens is when you're honing, you're putting so much pressure on each individual abrasive. And the more pressure you put on that individual abrasive, the more tendency you have to distort the bore. And when you distort the bore, then you're really not making a round cylinder, and you're going to have ring sealing issues. So, you know, we've done tremendous amount of testing at Rottler, where we've used a 2-stone, a 4-stone, a 6-stone, an 8-stone, a 10, and a 12-stone hone head. You know, and we bought Dart big M blocks that are really stable, really thick, and used them to do our testing with, and then actually sent them to the Incometer people and had them check them for us. And we found that there's a huge difference between 2 and 4, another big difference between 4 and 6, and then you have the law of diminishing returns. So you can go to an 8, you can go to a 10, you can go to a 12, and in reality, for the difference in price and the lack of it's a much smaller range. So the more abrasives you put in a hone head, the less range it has. So you have to have more hone heads. So we've settled on a 6-stone hone head that works really, really well. There's 2 microns difference between a 6-stone and a 12-stone. And so the 6-stone is kind of the best of both worlds, gives you that nice big diameter range, but gives you the best roundness that you can get. And I've always been told, and I don't know if you guys have heard this, but from a ring manufacturer back 20 years ago, that anything more than a 0.2 deviation in a 22-degree arc is unsealable. In other words, the ring will not conform to more than a 0.2 variation in a 22-degree arc. Now, I don't know with today's rings, maybe they're better. But I've always used that principle as something that I've tried to explain to customers. So board geometry, in my opinion, surface finish is important, but board geometry is the ultimate.
Well, Keith, you want to jump in on this as well? I mean, I think Lake gave you a pretty good intro as one of the smartest people in the room. So, based on what Ed was just talking about as far as the ring sealing and everything, what are your thoughts?
Well, I agree completely, and thanks for the compliments from Lake and Ed. I'm no expert. I've just been doing this a long time, so
that makes you an expert, by the way. That's hard-earned experience, buddy.
It's something. But as Ed was talking about, the ability of the ring to conform, and of course, I'm looking for a ring laying on my desk, and it's probably the one thing. Here we go. Let me grab one here. It's always good to have show and tell. Got a nice little diamond finish ring here. And one of the things I was talking about, we have two dimensions we look at in the ring. We have the axial thickness, top to bottom, and then we have the radial dimension, face to the inside edge. And one of the dimensions, one of the things that's changed dramatically in rings over the years is the reduction of this thickness, the radial dimension. As this dimension gets shallower and thinner, it allows the ring to follow and bend and distort, conform, follow that bore distortion that Ed was just talking about. That deeper that number, the stiffer, the tougher it is to bend and flex and move that ring. So in the modern ring world, we're seeing rings that have radial depths at 100,000, some engines 85 thousandths, where 8 or 9 years ago, it might have been 185 thousandths or 200 thousandths. Much shallower depth on that ring, allowing that improved flexibility and improved conformability of the ring. That's a big part of what's happened today in piston rings. And one of our other designs that we've implemented is to actually put small little radial slots on the inside edge of the ring. We call our Total Conform. Those generally cater to the higher end markets, cost a little more money. I think maybe Lake's got one there. And that allows the ring to, again, flex and follow and move and follow that bore distortion. Things have changed dramatically. Today we're dealing with aluminum blocks with sleeved aluminum blocks, or in many cases, no sleeve at all, just a coated aluminum block. We don't have the stiffness, the rigidity that we used to have years ago when we dealt with big, heavy cast iron blocks. Well, that thing's trying to focus on everything but the ring. and I got to tell you, what a great backdrop in Lake's thought. Hey, there we go, winner. That's the Total Conform ring. You can see all the radial slots. Allows that ring to flex and follow bore distortion. Because as good as it is and as stiff as you think that block is, trust me, they move quite a bit. And I'm going to throw out a quick story, kind of like Lake had a minute ago. We had, this is a few years back, we had one of our 360 sprint car blocks and would have this engine built. And every time we tore this thing apart, we'd notice in the outboard 4 cylinders, about mid-stroke in the cylinder, the crosshatch was worn out. Good at the top, good at the bottom. In the middle of the boards, it's losing the cylinder finish. Only in the outboard 4 cylinders. So hone it, straight round, best we can tell, run it again, same thing. It does this about 3 times. And, I'm looking at it, I'm trying to, wrap around my head what the heck would be doing this. It's being done in a vertical hone. So light bulb goes off. Okay, what's the one thing I'm not doing to this? We're torque plating it. We're doing everything we can to simulate running conditions. We're not simulating water pressure. This thing runs at about 20 PSI of water pressure in this block. So torque plated it up, hooked up a bicycle pump, started pumping her up at about 20 PSI of pressure in that block. Guess what? The outboard 4 holes tightened up about 3 thousandths in the middle of the cylinder. Just from the cooling system pressure, it tightened up those cylinders as they weren't supported the same. So everything we can do to try to replicate that running condition it's an important thing. But again, that goes back to as tough and as stiff as we thought this thing was, 125 thousandths thick liners, just the introduction of water pressure tightened the cylinders up that much. And again, that comes back to that ring being able to follow that bore distortion.
Wow, that's big. Hey, Lake, for anyone who might have their Zoom right now set to like speaker priority, will you talk so everyone can see the picture and show that ring again?
Yeah,
I'm
sure.
not sure if anyone got to see the whole thing.
I'll talk and I'll try to get my head out of the way so I can so that we'll focus on the ring, right? That's the tricky part, is getting the camera to focus on the ring.
Perfecto.
Okay, I think you can see it now, right? Oh yeah. Those little radial slots in the back allow it to bend locally. So if you can take a regular like 16th ring, that's they call it a D wall, which would be about 200 thousandths radial thick, and you try to bend it, it won't bend at all, really. Where this one, you can actually bend it locally. You can actually kind of see how it conforms and bends. We've actually seen these rings in a billet aluminum block application cut blow by in half, just because that billet block is going to move so much because it's billet aluminum, and the temperature expansion makes a big difference, that just by adding a ring that can conform to those variations, like Keith and Ed were talking about, the blow by is cut in half. So it's a big deal. You know, conformability is everything. So between the two, right, between a conforming ring and improved cylinder honing techniques to get better bore geometry, now you can get really good ring seal. And it's ring seal is two things. It's, like I said, it's horsepower. That's the other thing, or that's the main thing. But the other part of it is, you know, blow by is what kills your oil. I mean, people that know me know I'm a tribologist, I'm an oil guy. And the thing that makes the difference between motor oil and gear oil or transmission fluid, the reason motor oil doesn't live as long isn't because chemically it's different, you know, that the base oil is different than transmission fluid or gear oil. It's the exact same base oils typically. You know, the additive package is different for the application. And one of the main differences for the additives is we put detergents and dispersants and things in motor oil because there's combustion blow by. We get fuel dilution, you get combustion blow by in the oil, and that's what chemically degrades the oil. That's what makes it go away. That's why we're such a big believer in used oil analysis here at Total Seals, because fuel dilution is typically what actually ends up hurting your piston rings. If everything's working right, your piston rings shouldn't have a problem. But if you get a bunch of fuel in the oil, that's what's going to hurt the piston ring. So if you can reduce blow by, you reduce contamination of the oil. Therefore, the oil will live longer and do its job better, because one thing people don't know about oil is that the ZDP that we know reduces camshaft wear and reduces wear in the engine is also what's called an antioxidant. And when you have 1,000, 1,500 degrees exhaust gas blowing by the rings, getting into the crankcase, it consumes the ZDP as a secondary antioxidant. Now, the volume of ZDP in the oil, if you check it by analysis, looks the same. But chemically, it's not able to provide the wear protection it does. So if you get less blow by, you will get longer engine life by default, because your oil will do a better job. So it's power and durability. It's the best of both worlds, is having your cake and eating it too chemically.
Keith, I'm curious, you were talking about, you know, when the PSI increased, that you had a little bit of distortion. Now, that was pumping it up with a bicycle pump, right? So when we're talking about 20 PSI going through there, also with coolant, which is heated up, how much does that change? Does that make a difference?
Absolutely. You know, the thermal characteristics, as Lake, you know, just described, you know, or what is known in, you know, in our industry as hot honing. Yeah, absolutely. Just the metallurgic distortions are incredible in these things, especially in aluminum blocks. One of the things that may or may not be understood is, you know, a forged piece versus a billet piece. You know, when we're machining from a solid chunk of billet, once you do all that machine work, there's a lot of what's referred to as compressed stress in that product. And we have to get that stresses out. One of the things that does it is the heat cycling of that part. And the more we heat cycle, the more it keeps moving. It wants to keep distorting. So yeah, heat becomes an issue. The pressures that are internal to the engine become an issue. They'll move the deck around, they'll flex the block, you know, they'll move the cylinder. So yeah, as Lake likes to put it, you know, it is a soup, and this soup is, you know, it's all encompassing. It's not just pistons, rings, it's the cylinder, it's the block. It is all of these things involved together. You know, we run into so many, we'll say, diagnostic challenges every day. I had a gentleman yesterday, and this is kind of off subject, but he's got a circle track engine and keeps wearing cylinders out in about 3 nights racing, which he shouldn't be doing. And we're going through all the things, cylinder finish, how he's doing it, what kind of oil he's doing. And this, you know, just this one simple thing that he missed, you know, we're going over everything. as Lake described, fuel wash, everything he's describing to me is a fuel wash situation. I said, you've got a mechanical fitment, which is either the rings butted in the ends together or bottom in the groove. He checked all that, so we don't have a mechanical binding problem. I said, next is going to be some sort of a lack of lubrication. Either we're not honing the cylinders correctly, or we're getting into a fuel dilution problem. We go over everything. Cylinder prep sounds like he's doing it the right way. Doesn't have a profilometer, but just through history of knowing what we know, it's like, that should be pretty close. You're not way out here in left field somewhere. You ought to be pretty close. We go over everything, and I said, so we're back to, and I love this. Oh, I did everything the same, and yet it's different. Well, if you did everything exactly the same as the other time, we're going to expect the same results. So we kept digging, and I go, have they changed brands of fuel at the track? Oh, yeah. It went from brand V to brand S. But how could that make a difference? Anybody that's raced NHRA Pro Stock or any classes where we went from one brand of fuel to another brand of fuel, octane rating may be the same, but as I know Lake knows, atomization rates, specific gravities, very, very different things, which in this particular gentleman's case means a whole rework of that carburetor. I said, you need to get with your carburetor guy. You've got a fuel wash problem. And
it's huge. And Ed's a great guy to speak on this because, Keith, you see this all the time, that fuel wash is your enemy. And sometimes you're stuck with certain fuels and you have to work around it. And, the difference between, say, a gasoline engine and a methanol engine, because of the composition of the fuel chemically, you have to run twice as much methanol as you do gasoline, essentially. So you're going to have more fuel in the cylinder. So Ed, talk about how we change the honing process in order to compensate for that higher volume of fuel that's going to be exposed to the rings and the cylinders.
Yep. So you're absolutely right, Nick, and I've learned a lot of from Keith. So thank you, Keith. But, you're absolutely right. What you have is you have the fuel wash, and really what we're talking about is we're washing the oil off of the cylinders, lubricate the piston rings, and seal them. And so, in order to try to maintain that oil, we need a larger, I'll call it a groove or trough or what have you. In profilometer terms, it's RVK. And so when we're changing fuels, we're going to a methanol or we're going to a blow-in application or a nitrous application or a turbo application, we're trying to wash that oil off of the cylinder walls. And so we need that deeper groove. So we'll go in with say 170 grit diamond where most people would finish with a 400 grit diamond. And we'll create the grooves, and then we'll go on top of it with a 600 grit diamond. That's what the ring sees. And the ring, as Keith and Lake both tell you, we're typically in the 10 to 20 RPK range, and we can vary that between a 500 grit CBN, which we're going to give you 15 to 20 RPK, or if you want a little lower RPK, we can go to a 600 grit and give you 10 to 15 RPK. I'm sorry. So it's all about that base finish. It's all about that deep groove to allow that oil to set on that cylinder wall and seal the ring and lubricate.
Well, exactly, Ed. And I'm going to grab my profilometer real quick so we can, if people don't know what we're talking about.
Thank you. I was curious about that, because especially when you start hearing about terminology that we don't typically talk about every day. While you're doing that real quick too, I do want to remind you that if you're tuned in right now and you do have a question for any of our panelists or a general question as well, feel free to type it into the chat. A lot of fun things to talk about and absolutely a lot to learn today. Lake?
Yeah, no problem. So this little handy tool right here is called a profilometer. This happens to be a Mitutoyo SJ210. And I'm going to try to make it where this thing can focus on. Oh, perfect. There we go. You can see the numbers. It's going to give you what's called RA, which is your roughness average, of the number that a lot of people know about. But that really isn't the number that you really want to focus on for cylinders. Like you said, it's the RPK, RVK, and the RK. And like Ed said, RPK is what the ring interacts with. So you'd like to have that as a lower number, a little smoother. That way it's not as rough on the ring. But like Ed said, you got to have enough valley to hold the oil, to one, lubricate the ring, and number two, be able to actually be that gasket, provide the seal. So the RVK is that other really important valley number. And then, the RK is your core roughness. That kind of works out through the process a little bit. And we could spend an hour just talking about surface finish alone and getting into all the details there. And there's even other parameters like RQ and things like that, we're going to get to one day. We'll have another webinar just about surface finish values and how important they are. But this tool right here gives you the ability to measure it. And like what Ed was talking about is it gives you this trace. Now I'll give it a second here for the screen to die out for a second, and it'll probably help us out. There we go. And you can see there's that roughness trace. Now this is a machined piece, not a cylinder that we were measuring, because you can use this to measure more than just cylinders. But those peaks and valleys are what you're looking at. In this case, there's more peaks than there is valleys. So this would be a horrible surface finish for a cylinder. If you can imagine turning it upside down, it gets slightly better, But the idea is, you want to have those valleys to hold the oil, and you want the peaks to be down to be able to have a good area to support the ring, for the ring to seal against, and again, be the lubricant and provide that seal.
Is there too deep of a valley, when you compare it to like what you have for the plateau? Is there possible for it to be too deep? Like, what's bad?
I don't think so. I mean, Keith may have a different opinion.
I'd leave that up to the wizard, Keith. He's the guy that can talk to you about that.
Yeah, when it comes to RVK numbers, the valley depth, to say the words, you can get it too deep based on, what your oil retention is. We've got so much oil retention on the board. Let's say for argument's sake, we've got a RVK of 150, but I've only got a 5-pound oil ring on it. Yeah, you're gonna simply overwhelm that oil ring. There's so much oil there that the oil ring simply can't scrape it down. It can't get rid of it. It just can't return it back into the pan. But you've got a lot more latitude than a lot of people think. That you can get away with a fair amount of RVK. There are ratios, there are numbers that we try to stick to, that through experience and customer, feedback, and we rely on that a lot. Hey, this really worked, that didn't work. We have to take all that information and digest it, see what the best, see where, we'll say the average it out, what seems to be working the best for everybody. But at the same time, we welcome all the questions. We welcome the phone calls, the emails about their specific application. Hey, this is what I'm doing. It's 11,000 RPM. It's 20 inches of vacuum in the engine. Here's my ring pack. Where do you think I need to be? We really want to help fine tune that. But in overall, you can generally get away with a bit more RVK. I'd rather see that number be a little too high than a little too low. If it's too high, through natural wear in the engine, the rings will correct that bore finish. If we start off a little bit off, they are going to do it. We go back, historically to the 60s, the 70s, we had one way of honing. We did everything the same. We had big 5/64 rings and 20-pound 3/16 oil rings, and finish be damned. The rings are going to make the cylinder finish what it wants through just the natural course of running. They're going to wear the bore into where it needs to be. In today's world, we've got much harder blocks, much better quality oil, and much thinner, much lighter drag rings. Now, again, will that ring eventually wear that incorrect bore finish into what it wants? Yeah, in time, but probably not in your lifetime. And nobody wants to wait for that. Everybody wants it right now. They want to fire that thing, boom, boom, boom. Yep, she's dry, good, let's hit the track. So we have to do the things that the rings are going to do ahead of time. That's plateau honing. That's getting that great bore geometry, getting that surface finish so that we can literally light it up. Hey, check the timing. It's not leaking. Let's go. We want that instant result these days. So that's a big part of why we have to do what we're doing. Not only that, again, increased block hardnesses, thinner rings, harder coatings, better oils. We've got to do it in the hone. Again, the engine will do it over time, but you're never going to want to wait that long.
Yeah,
it's a great. Go ahead.
Sorry, go ahead, Lee.
I was going to say, Keith was mentioning about the different bore materials and stuff, block materials. And I think, Ed, why don't you talk a little bit about how those changes in, block material and bore material have changed not only how you machine, but also abrasives as well. Because I know there in the old days, right? Everyone just had a regular old hone, and you ran vitrified stones in it, and that's what the whole world was. But today you've got, like you said, diamonds and CBN and things like that, and you've got water-based coolants. Talk a little bit about how those changes in block material have now impacted your choices of abrasive and coolant.
Sure. So what you see is Keith talks a lot about this in most of his presentations, and it's the Brinell hardness in a material. The years back, like Keith was saying, we run these rings, everybody honed the same way, they put the same rings in, and boom, everything was fine. But in today's world, you have the stock blocks with a certain Brinell, and then you have the racing blocks that have a certain or harder Brinell, and then we get into the liners, the liners that are even harder than the typical race blocks. And so what that creates is there's a certain amount of pressure that you use when you're honing, and you get what we call grit penetration. And that grit penetration is what's going to give you your RVK. And as we get up into the harder Brinells, it's such a fine line in the honing application. If you put enough pressure on a cylinder to create that deeper scratch, let's say, with the same grit size, then you distort the bores. So you always refer to this as a soup, Lake. It is absolutely a soup. So we have to manage the pressure that we put onto the cylinder wall during the honing process with the proper grit size to give you the proper RVK. So we tend to go down in our grit sizes. Perfect example is depending on what RVK you want. Let's just say typically we want a 55 RVK. Well, in a stock block, a 270 grit diamond will do a great job in giving you that type of RVK. But in a dart and liner, you're not going to get close to that 55 RVK. You're going to be down in a 140 grit on a dart and liner, and a 170 grit on a dart block, let's say. Now somebody will chime in and say, "Holy cripe! That means I got to have all these different grits." The neat thing about plateau honing is we create a trough. That's our number one priority, is to create that trough for that oil, and we tend to create too large a trough. Well, now with plateau honing, as we go over the top of that, and 600 or the 500 grit CBN, and it will not affect our RPK. The RPK is a given. When you 500 grit or a 600 grit, your RPK is more or less locked in. And so all it does is if a customer tells me he's going to be doing dart and liners, I'm going to sell him a 140 grit diamond, and I'm going to tell him to hone 25 strokes with the CBN instead of 18 strokes. So it's a soup. And but we've gotten pretty good at being able to help the customer with maybe 2 grit sizes and be able to adapt to any finish that he may want.
Wow. We have a question. Oh, I'm sorry. Go ahead, Ed.
Oh, no, go ahead. I like drawing a picture, Brad.
All right, I have to illustrate, right? So if you're using what Ed was saying, right, that 170 is going to create these big valleys, right, troughs. But then what you do is you come back over with the 600. When we're plateau honing, it's essentially doing like this, right? We're taking it off. Then you can get it down. How much valley you leave is based on how much material you remove. The old days, these guys have 3-step processes where you take one grit and you go, say, to within 2/1000ths of size. Well, then you go to 1/1000th of size with the next grit. And then you go to 1/2 a tenth or 3/10 from size with the final abrasive. Then you maybe brush over that or something to kind of get it right. Well, a lot of what that's doing is moving all this stuff out of the way. With this process, like Ed's saying, you're going to go to size with that 170, And then you're just going to do probably 8, 10 strokes, depending upon the grit of the abrasive and hardness of the material, how much load you got to apply with the 600. And it's just going to come across and provide this. So you got that little bit of roughness on the top. So the ring has a smooth place to ride against, but you got these valleys to hold the oil. So I mean, this is definitely an exaggeration, nowhere near accurate, but just to kind of give you a visual representation of what Ed was talking about, this is that idea, that process, which is why you can do it with only 2 abrasives if they're far enough apart.
It is
I
pretty
want to kind of jump in if I
fascinating.
can here and expand on what Lake was just talking about, what Ed was just talking about. I recently had the honor of spending a day with Mark Malberg, who is, we'll say, one of the gurus on surface finishing. And we spent a lot of time looking at 3D metrology. You know, right now we're looking at 2-dimensional graphs and charts, but his expertise is in 3D, the visual, you know, we'll say reflection of what we're looking at here. And we talked in great depth about plateau honing. And one of the things that he really latched onto and we talked about a lot is, again, the multi-step process coming in with, you know, oh, I roughed it with a 70, then I sized it with a 200, then I came back in with a 220. And all of these processes are just looking to add a disaster. We're just putting fuel. It really, you're going to have a roughing process, and then really we're going to bring it to size and we're going to plateau it. We're going to use an aggressive stone, and then we're going to plateau to create what he refers to as an extreme plateaued condition. A lot of flat with a deep valley. But one of the things that he really emphasized was lots of strokes, very light pressure. Because what he saw, and here's my illustration, I don't know if you can see that.
Ah, yes.
He had the 3D imaging of this showing how it rolls the peaks over and creates this nice little shelf. So instead of cutting that peak off, or as he and I referred to as sanding the surface down, we were literally plowing it, grinding it, whatever you want to call it. Instead of slowly sanding it, we rolled all the peaks over. And now we've got that little shelf sitting there ready, waiting to wear down and break off. And that debris then gets into the oil, into the ring grooves, into the skirt of the piston. We see all this scuffing, all this scratching the bore. And from where he's at, with his ability to really, truly analyze this, it is how we're rolling that shelf, that peak over and not cutting it off cleanly. And that stuff, that we'll call it that junk, is just sitting there waiting to contaminate your engine. So lots of strokes, light pressure during the plateauing process.
Ooh, good stuff.
Good stuff. And Brad, that's one of the reasons that people ask all the time, why do you rough with a diamond and you finish with a CBN or cubic boron nitride? And the reasoning for that is a diamond, although obviously one of the hardest materials on earth, it's a dull particle, and so it tears and plows and rolls like Keith just showed you. The CBN is a much sharper abrasive and does a much better job of clean cutting. So that's the reason for the 2 different abrasive types that we use in the plateau honing process.
Wow, this truly is fascinating. Yeah, it's not like we're sanding down furniture to stain it. Obviously, it's not about getting it smoother; it's about getting it right. One of the questions that we had presented beforehand: steel piston rings requiring different honing method than plasma moly rings. What can one of you tell us about that?
Mr. Jones, you're the expert on that one. That's your bailiwick.
Mr. Jones.
I can jump on that. Interesting question. And what I'll put down is it's really not the steel versus the iron. When you're talking about the steel ring or the iron ring, you're talking about the material, the base material that the ring itself is made out of. That is really not a running surface or a contact surface. What you're talking about is the face coating, the coating on the face of the ring where it actually meets the cylinder bore. And this particular one, I got to get a little light on it here. That one's titanium. That's got a nitride on it. So it's a relatively hard coating. This coating typically runs about 2,300 to 2,500 Vickers. So it's a pretty hard coating. Molybdenum, on the other hand, moly's about 850, 900. So it's a very soft coating by comparison. The other thing about it is it's very oleophilic. It likes to hold oil. Think about the porosity that's in that coating. So it sucks oil up like a sponge. So really the difference is the coating. And as the coatings on the rings get harder and harder, they don't want to hold oil. Let's say, you've got the oil retention that's done by the cylinder wall, then you've got molybdenum. It's kind of holding some oil as well. So it's an insurance policy. It's kind of a backup. You can kind of miss this one a little bit because this one's holding a little oil as well. The two twain shall meet. We've got a reasonably safe environment here. You start getting into the hard coatings that we deal with today, well, all the oil retentions in the wall is this coating maybe has 2, 3, 4% porosity, where molybdenum can be up to about 40%. So we've got to make sure that all the oil retentions in the cylinder wall. That's why getting that finish is so critical when we get into the harder coatings. Not so much iron versus steel, it's the coating that's on the ring.
Okay. I do want to get a couple of panelist questions in real quick, if you gentlemen don't mind. So this one says, so for NA, boosted, nitrous, and various fuels, what are your recommended RVK values? Does ring composition change your target RPK or RVK? Do you recommend any change in oil ring tension or size for boosted applications? I personally have always moved toward larger oil rings with elevated tension when increasing the RVK. I'm really wondering what your recommended recipe is.
Well, if you guys don't mind, I'll kind of grab onto that one as well. Our PK numbers, the peak roughness number, that's a fairly constant number. There are some times where we'll swing it a little this way, swing it a little that way. But generally speaking, for most applications, your RPK number is going to be around 10 to 15. There are some times you want a little bit lower, sometimes you want a little bit higher, but that's generally a fairly fixed number. Now, the RVK, on the other hand, that does change. That's going to change with the amount of fuel, vacuum engine, no vacuum engine, how much cylinder pressure we're dealing with. So I'll throw out what I'll call a general number. This is 99% of what's out there, kind of general application. RPK numbers, you're going to be about 10 to 15. RK numbers, you're going to be in the 40s, plus minus a bit. Everything's got a little plus minus on it. And RVK numbers around a 50. Let's call it, 10, 40, 50. That's going to get 99% of what's going out there. There are applications where we're going to be lower than that, maybe real thin rings, NASCAR, Pro Stock. But as we start going up on power adders, more fuel, more cylinder pressure, and mainly more fuel, a lot more fuel, we're going to start bringing that RVK number up. You get into, say, a modern Pro Mod engine, 4,000, 5,000 horsepower. I'm going to look for RVK numbers in the 70, 80 range. I'm dealing with so much more cylinder pressure, so much more fuel. I generally want my RK numbers to be, say 10 points lower than the VK. But as that goes up, that RVK number is just going to keep going up. What we like to refer to as crazy tractor stuff these days. 200 pounds of boost, 4,000 horsepower, pouring everything through it you can think of: gasoline, alcohol, toluene, diesel. I mean, it is, talk about a soup of fuels. They pour everything through this thing. We're seeing RVK numbers on these in the 150 range. To keep the oil on the board, we're dealing with so much fuel going through that engine. So typically speaking, as the boost pressure goes up, the power levels go up, the amount of fuel going through it, the RVK's got to go up with it.
Wow. All right. A follow-up on that too. It said, without owning a profilometer, is there a recommendation that you have for the machinist for plateau honing? Goes on to say, since purchasing a profilometer, it seems that the plateau honing is getting overdone all too often. Being just a customer, it makes it very difficult for me to explain to them that it doesn't take as much plateau as they might think.
I mean, I think any of us can grab onto that. What do you think, Blake?
Well, to me, this thing's $2,500. If you're spending $10,000, $20,000, $30,000 on a race engine, and you're competing for championships, this is a pretty affordable tool. So I would argue the point that even if you're the end customer, this is a worthwhile piece of investment to make sure that it's right. Because like you said, it's pretty easy to take too much out. And the reason why this is a long way of getting to the answer is you can't just say, oh, use this abrasive to go to size, this abrasive to finish with. You're always going to end up at the same number. Well, that's true if it's always the same operator at the hone. The stones are always dressed the exact same way. The coolant's always in the same condition. And oh, by the way, the hardness and the metallurgy of the block is always the same. That's a whole lot of assuming. Ed, tell me if I'm wrong. I would love to hear your opinion on this, but all those variables to me are things that actually vary every single day in a shop. And Ed, you've got, way more experience honing than me. Why don't you elaborate on those variables a little bit?
Lake, you're just right on. There's just, I mean, you really can't add to that. You've summed it up perfectly. I guess I'll use the analogy, as we know, and many of our customers that are probably listening today, they're racers and they're engine builders. And the three of us, or Brad, even you can attest to this, racers are very skeptical people. Okay, they don't take things at your word. They are going to prove it and show themselves that it worked. That's right. They're all from Missouri. Amen. I have yet, when we go into a shop and we're lucky enough to sell a shop a new machine, and I take my profilometer, I carry one. It's on my hip. It's attached. I carry my profilometer in, and the first thing we do is we do a trace of before the new hone and after the new hone, and we take the time to explain and train and teach people. And we've sold hundreds of these things now in the last 4 or 5 years. I can tell you, I have not had one of those skeptical guys come back to me and said, geez, I didn't seal my motor up any better, or I made less horsepower. Every one of them has a smile on their face when I walk in the door, and they're like, this is the greatest thing we ever bought in our life. It does make a difference. I know, guys are out there and they're saying, I've been doing it this way for 30 years and I've had success. And they have. And I'm not saying that they're still not having success, but I'm going to tell you, the guy next to them that bought the hone and spent the time to listen to these guys at Total Seal and Plateau Finish, I promise you they're making more horsepower. I promise you.
I've got to jump into where Ed just was talking about and just kind of follow up on that, because I do deal with this every day, and I've got the guys that, hey, I've been doing this for, since 1960, and they're great guys, and they've built thousands of great engines. And the truth is, whether it's our rings or somebody else's rings, hey, folks, the rings have changed, the blocks have changed, the oils have changed. You have to move forward with the modern times. Otherwise, you're going to be stuck in the past. You're going to have the same thing you had before. You're going to have the same problems you had before. I hear these all the time. I just can't get it sealed up the way it used to. What did you guys change? Well, we changed some things, but a lot of things have changed, and you have to move with the times. As Ed and Lake just said, the profilometer is not that dear of an investment when you consider what that race engine costs, or what that machine shop just spent on a new hone, all the tooling that goes with it. This is just one way to verify and measure and check your work. I like saying this, hey, I port the best cylinder head you've ever seen till you flow them. They're horrible. You want to knock 20 horsepower to your junk, you put my heads on there, because they don't work. Why don't they work? Because I don't have a flow bench. The hone's only as good as the operator, the tooling, the condition. As Lake said, within one block, I have personally measured 20-point hardness in front to back on the block. It took an entirely different honing process to get the back of the block the same as the front of the block. And in that engine, we picked up 13 horsepower average just getting all 8 holes the same. And this was not a bad engine. I'm not going to go down the whole path, but this was a championship winning engine. It wasn't a back marker. This thing ran good. They were just leaving some on the table, and in their case, quite a bit on the table that they didn't even know was there. I have guys that buy profilometers, end users. They'll get together, 2, 3 guys, 4 guys, because you just know they're not getting what they want. There's nobody in their area. They'll get together and buy one for their own use just to check it. So, again, nobody here is trying to force you into this thing, but that type of tool is not expensive in the big picture of things, and it's a truth detector, because it's going to tell you what you have. It's not lying.
Right. And just a little side story, just to address the variation in block hardness for the same cast piece. There was a guy who used to work at Joe Gibbs Racing, the engine shop. His name was Tex, and he was the guy that honed all the blocks. And, Tex was, old school guy. Tex could tell you which blocks were going to be good and which ones were going to be bad. And by good and bad, I mean horsepower on the dyno. He would hone a block. He could tell the guys, this one's going to be a good one, or this one's going to be a bad one, because he could hear and feel that difference in hardness in each block when he would hone it as a brand new one. In fact, it got to the point where Mark and the guys there at Gibbs would just listen to text. If he said this was no good, then that engine would just get put together to be a dyno mule engine for a while until it had some time to season in. And then when he said, oh, this is good again, all right, now that one could go be a race engine, because it would literally be like 4 or 5 horsepower difference just in the block, just the composition of it. And anybody knows anything about NASCAR, 1, 2 horsepower, kind of a big deal. 4 or 5, you cut your right arm off of that, especially in a plate engine. So it's real. I mean, that variation in block to block to block, it's not that you're picking on or throwing stones at any manufacturers. It's just the nature of the process. If you've ever been to a foundry, or go watch on YouTube and see how a foundry works, you're throwing stuff in a thing and mixing it around. It's hard for it to be exactly the same over and over again. There's going to be a plus minus spec on it. So what we're saying is this tool gives you the opportunity to truth detect and see how different this one is compared to the other one. That way you can change your process if you need to adapt for that variation that's going to inevitably be there.
Wow, that's big. There's a comment here on the chat that I think it's worth throwing out there. Robert Day, it says, I was all in until we talked CBN. I haven't done yet. I drive myself crazy with surface, as Lake knows by the stuff I've sent him. I follow right to size method, and it always seems to be a great plan, but not all blocks are the same, and actually not even all cylinders are the same, and we very seldom know the history. So patience is just as important as the equipment. I mean, look, these details are no different than, I mean, I think of just analogies of people checking, grabbing a durometer and checking the tires, or doing different things like this. I mean, why should you not be doing this in your cylinders?
Well, that's, Brad, that's a perfect analogy. Anyone that's a racer, right? If tires are the single most important thing in a race car, period. If you go race car vehicle dynamics, the very first chapter is tires, right? And it's not because the book's alphabetical, okay? There's a reason it's the first chapter. That durometer of the tire is everything. And then the run out of that tire is the next biggest thing. So if you're going to own a durometer and you're going to measure and check your tires, why would you not check the hardness of your block? Because the block is the foundation of the engine. Just saying.
One of the things we talked about, just for a moment, I just want to jump in here. If you've got the profilometer, what I like to say is baby step this thing. Don't wait till you're done honing the block to check it. You need to check it along the path. It's like your GPS. Don't wait till the final end to go, hey, am I here? Now you want to check it turn by turn. So when you've got the block to size, you need to stop and check it. If I'm looking, to have an RVK when I'm all said and done at say a 50, when I'm sitting at size prior to plateauing, I better have a 70 or 80. It's got to be up here so I can bring it down to here. If I start here, it's only going lower. If I'm sitting at size at a 50 and I want to be at a 50, guess what? Your 50 is going to become a 30. So stop at size, check it, look to see where you're at. If you don't have that RVK number, that's telling you right there, as Ed knows, you're not using the right abrasive. You're not aggressive enough on the abrasive to lay that valley in there. Then when it comes to the plateauing, again, baby steps. Come in, check it a few strokes, see where you're at. Check it a few strokes, see where you're at. You can always keep going. You can always kind of creep up on it. But when you've overdone it, as was mentioned earlier, it's hard to go back and put it back. The metal taker offer works better than the metal putter on.
I like that. Hey, real quick, and Lake, maybe you and Ed can answer this, because I know, Lake, you showed us your profilometer. If you could give the model and make of that one, and maybe Ed, if the one that you carry around is something different, just to give some people an idea of if they are looking for something, what they should buy.
All right, this is a Mitutoyo SJ210 is what I carry around. I think Ed has the same one. And, not to be a commercial here, you can buy these things from a lot of places, Amazon and all that. If you happen to buy it from Total Seal, the difference is it shows up in the box and it's already been calibrated programmed. All the settings have already been set up by Mr. Jones right there. He's the one that sets all these things up personally. And then we also have a really cool tool made by Brad Lagman at QMP Racing Engines, because this is hard to fit in a cylinder bore, but this little piece will come off. It actually has an extension cord, so you can put this in the cylinder bore. Well, you don't want to hold it with your hands. So there's a tool that comes with the Profilometer bundle that actually locks on this, and it holds it in the bore, and it comes with various sizes, so you can run different cylinder bores. So you can check up here, you can check down there, you can check here, you can check there. You can check the bore in multiple places and get an average, because that's the best way to do it. So that Profilometer bundle we sell through Total Seal is $2,500 on our website. And again, it comes with all the stuff, and it's ready to go. It's probably the best deal out there, I think, if you're serious about doing this.
I'll second that motion. It's absolutely the best deal. I mean, Rottler looked at even supplying these, and we can't buy them for what Total Seal sells them to the end user for. So if you're thinking about a profilometer, honest to gosh, call Lake or call Keith and get one set up. I personally carry a 310. It has a printer on it, so I'm able to print things out for customers and show them before and afters. And that's the only reason I carry that. Has no more capability than the one that Total Seal sells. I just do it because mine has a printer on it.
Wow. This has been, again, I think we could probably do this for like 5 more hours and still not cover everything. So it's pretty awesome to come on here. Lake, Keith, Ed, really appreciate you. Of course, check out Rottler, check out Total Seal, through the ePar Trade page and their pages on that. And gentlemen, we really appreciate it. This has just been a fascinating hour of learning.
Well, thank you, Brad. We appreciate Judy and Francique and John and the whole group there at ePar Trade for allowing us the privilege to come and hang out and talk and sound off like a bunch of idiots, So it's good.
That's why we invited you so many times, Zach, right?
Yeah.
So thank you very, very much. What a fascinating webinar. It has been recorded. It will be posted later on today on the ePar platform and on our YouTube channel. We also pushed Rottler and Total Seal back the homepage, so please take advantage of it. We will back next Wednesday. We're going to be talking racing pistons with Mane Motorsport. So again, thank you very much for being with us today, and let's go racing. Thank you. Bye-bye.
Thank you.
Thank you, everybody. Appreciate it.
Yep. Thanks, Brad.
Thank you.
Registering on ePar Trade is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use ePar Trade as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to ePar Trade.